The WrapNode is the next big innovation when it comes to offshore wind, solar and ocean energy structures. A revolutionary bonded connection where the welded connection is replaced by wrapping the flexible and durable composite material around the steel tubes. The composite has a fatigue life that is hundreds to thousands of times longer than steel equivalents. It will accelerate the construction process of tubular structures, like offshore wind turbine foundations, thereby helping to speed up the energy transition. In this video, the researchers and engineers on our team would like to tell their stories. From the conception of the idea to the development and extensive testing of this joining technology. And of course, the progress of the WrapNode and how it will evolve from this point on.
The inspiration for the WrapNode comes from Belgrade, a beautiful town where I spent many years. There is one large tree with very long branches, which people have supported with steel columns to help it grow even further. Over the decades, the tree grew around these columns, forming knots, a natural connection between the branches and the steel tubes. The tree did this in the most optimal shape, leading to smooth transfer of stresses. Since a tree is made of natural fibers, the idea came to me to create a similar connection using artificial fibers to connect steel tubes in huge man-made structures.
So we started designing a WrapNode that can connect steel tubes in a structure supporting a wind turbine offshore. At the beginning of the design phase, a list of requirements was created, describing things like water depth, turbine type and environmental conditions. In an iterative process, a design of the structure and joints was made that could withstand all the loads and meet the requirements of an operational wind turbine. We of course want to validate the performance of our design. We do this by first focusing on scaled-down tests of the joint and using these results to calibrate our models. The validated models will become an efficient and powerful tool to simulate the joint behavior, allowing us to predict the performance of other geometries, orientations and dimensions for the WrapNodes.
The WrapNodes must withstand offshore environmental conditions, where seawater will diffuse into the composite material. The presence of moisture degrades the material and the steel composite bonded interface. In addition, temperature changes will affect the mechanical behavior of the material and must also be considered in the design of the structure. For this reason, tests are performed on material and bonding samples under different temperatures and after long-term immersion in salt water. Experimental results are modeled into computational tools to consider the effect of environmental parameters on the performance of the structure.
So WrapNodes come in different forms of geometrical and load complexities. And to understand this, we look into complex and simple geometries. Simple geometries, X-joints in the different load directions and combinations are tested in the hexapod, also known as the Beast of Delft. And by performing all those experiments, we want to establish a solid understanding of the joint behavior and prediction models when the WrapNode is subject to multi-axial load conditions. And we are also looking into complex geometries by testing KK joints. And those joints connect the diagonals with the leg in the supporting structure. And those experiments help us establish knowledge and understanding to establish prediction models that can quantify the static and cyclic resistance of the WrapNode.
To understand how WrapNodes behave and perform in field applications, we need to consider dimensional size effects. The size effects are important for practical design because the joint capacity does not increase linearly with its sizes. Similar to an adult elephant having more relative bone mass compared to an infant elephant. We conducted both static and fatigue tests of a series of joint specimens to investigate such size effects. The tests enabled us to build up and develop reliable models in computer-aided engineering software to predict the resistance of joints in the design. The tests also showed that the real-size joint has superior static capacity and fatigue resistance compared to traditional welded steel joints.
In the future, the focus of WrapNode will move from the composite joints to testing the assembly of jackets using these joints, validating the performance of these jackets, and finalizing the prediction model by expanding the dataset of test results with more joint geometries and load scenarios.
Within the WrapNode project, we aim to collect all required information to validate prediction models in order to use these joints in offshore structures. In parallel, we develop manufacturing methods and design optimizations in order to scale up in line with the energy transition demands.
We are constantly searching for new test locations and project developers to collaborate in the project. If you're interested in joining the WrapNode program, visit our website